All right, here is the video for 412, and what we're going to do is we are working on writing equivalent expressions. All right, so in this lesson, you'll look very closely at a pattern. You'll look to work with your team to find different strategies for counting the number of tiles in the figure. Then you will apply your counting strategies to figure out figures are different sizes. In your discussion, consider the questions of how do we see it, how can we explain our thinking, how can we describe any figure. So, 412, look at the frame built with tiles at the right. Then use the diagram to complete parts A through D. Without talking to your teammates or counting every single tile, find the number of tiles in the frame mentally. Be ready to share your method and how you see it with your team and with your class. Okay. So I'm just looking at this. I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on there. Okay, I at least had to have that count. That I did have to count. Now without counting the rest, right? How can we get the rest? Well, with whatever method that you come up with, I hope that you come up with the same answer I have. The answer is 36. Did you have 40? Ooh, what happened? We'll talk about it. When everyone in your team's ready, we can talk about that. We're going to move on. Pam told her team that when she first looked at it, she thought there were 40 tiles in the frame. Explain how Pam might have been looking at the drawing to see this answer and what she might have overlooked. Well, if she counted 10 on that side and then did 10 times 4, what she did is she did then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's how she would have got her 40. But notice she counted this tile twice, this tile twice, this tile twice, and this one twice. And that one's not going to work, right? You can't count them twice. So that might be part of her problem. So below, here are some methods that students from another class use to find number of tiles in a problem. Which ones are like the ones the students in your class came up with? Which ones are new or different? For each method, describe how the student might have been seeing the picture frame to come up with the method, then add strategies with colors to the resources next to them. Save this for next class, which is Thursday. Jonas's method was 4 times 10 minus 4. All right. Again, I'd like you to really try doing this on your own. You can get this document in the lesson, but also in my weekly plan part. So if Jonah's method is 4 times 10 minus 4, it sure looks like Jonah decided to count and did 4 times 10, right? So I'm just going to do the 4 times 10 part, right, and count 40. But then Jonah, unlike what's her face right above us, Pam, Jonah did a good job and said, I have to subtract these 4 corners at least once because I double counted them if I did 4 times 10. Okay, let's go to Curran's method. Curran's method is 10 plus 9 plus 9 plus 8. Okay, so Curran's method, where's the 10? We did have that 10 up top. There's 10 plus 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Plus another 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then there's an 8. 1, 2, 3, 4, 5, 6, 7, 8. There it is. That's it for Curran's. Now you could, again, try these ahead of time. You do not, could you have done this and this? Could you have said, hey, you know what, this 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 is there, and you wanted to say the 8 was here? You bet. There's nothing wrong with that. You still have 10, 9, 9, 8. It just, in my mind, it made more sense to do it this way, okay? But whatever way, as long as you're still matching those up, right? Tina's method is 10 plus 10 plus 8 plus 8. Okay. So let's do the 10. Obviously, we know there's 10 on top. There we go. To do another 10, the only way you could do that 10 is if you counted the bottom one. You cannot count, the sides are 9, right? So you would have to do this to do your other 10. Okay. All right, so Now let's do an 8. It looks like an 8 here. And let's do that. That 8 is going to be an 8 here. There we go. All right, let's go to Raymond. Raymond has 10 times 10 minus 8 times 8. Woo! That's a tough one. How do we do that? 10 times 10. Well, what Raymond is doing is Raymond is looking at this as an area problem. And what Raymond is doing when he does a 10 by 10 is he is counting all of the tiles. So Raymond with 10 by 10 is saying, I am counting all of this by saying 10 by 10, which is 100, right? So that's 100. But he realizes that he needs to eliminate what's on the inside because this does not count for those tiles. That's a pretty sophisticated way of thinking of that, and pretty tough, right? But 100 minus 64 does indeed still get you 36, doesn't it? In fact, if we check all of them, they should still always get us 36. Okay. Alyssa's method is 9 times 4. Well, let's look. We need to find those 9s. There's a 9. This one's going to be weird. Another 9. And another 9. And another 9. There we go. So we have 4 groups of 9 with that one. TJ's method is 4 times 8 plus 4. All right, 4 times 8. 8. Well, that's big. 8. And we could do a plus 4. Now, could we have done it differently in different spots? Yeah, but I'm just trying to show it the way I think that they would see it, okay? Save this for Thursday's lesson. I just cruise through this. This usually takes a long time for kids to look at and process. Now imagine the frame from problem 412 has been shrunk, so it's 6 by 6. That means that instead of 10 along this side like that, that's that 10, we are having it 6, okay? All right, so with your team, consider the following questions without drawing the frame. Choose one method for counting the tiles and use it to find the number of tiles in that square's frame. Let me go up here. Oh, you know what? I'm going to use Alyssa's method, 9 times 4, right? What did we recognize? We recognized that we didn't do 6 times 4. We would do 9 times 5. Wait a second. Sorry. Let me try that again. 5 times, and how many sides do we have? 4. 5 times 4 to get us to 20, right? That's one way to do that. Now, you could choose another method. Well, actually, that's what B is. Choose another method. Let's try Tina's method, 10 plus 10 plus 8 plus 8. So the top part, right, would be 6. The bottom one would be 6. And the left one would be 6 minus the top and bottom, 4. And then the right one would be 6 minus the top and bottom, which is 4. Right? So that would give me 20 also. There we go. I would take a moment just to read through this, mixed numbers and fractions greater than 1, just to review that sort of thing, please. Closure. Imagine the frame had been enlarged to 100 by 100 tiles. How could you solve this? Use one of those methods up above, right? Use something, one of them. I don't know. What is it that you'd want to do, right? Let's try one we have not tried. 100 by 100. I'm going to try Jonah's method of 4 times 10, but I will subtract the 4 corners, okay? So this would be 100 times 4, right? Because that would be 100 on the top, 100 on the side, 100 on the bottom, 100 on the left, but I have to subtract the 4 corners because I double counted them. So that's 400 minus 4, 396 tiles. And if you chose a different method, you should hopefully get 396 too. Have a great day.